Okay, here's 1.3. This ties in with another video that I have out there regarding functions. So we may refer to Keebler's Elf Factory or Keebler's Cookie Factory, some in this. Might not, but that's the other one that's out there, this analogy that we're going to use throughout this course. So this is graphs of functions and how to read math, which might be the most important thing you get from this course, particularly if you go on and study math in college. Sometimes professors have a higher expectation. They don't really spoon feed you some information. They expect you to do some of the digging on your own. And a lot of the reading of the math rules is very, very abstract. So I want to try to get at that some. So let's talk about a little bit of that. So here we have increasing, this is a rule in the book, increasing, decreasing, and constant functions. A function f is increasing on an interval if for any x1, x2 in the interval, x1 is less than x2 implies that f of x1 is less than f of x2. That's just a horrible way to read this, but some terminology we have to get through. And if they're talking about an interval of a graph, they're talking about going along the x-axis. Let's say from maybe here to here. That would be an interval of the x-axis. And they're telling us that we have a point on that interval that's less than another point, x1 to x2. So that would imply that this would be our x1 on the interval to x2. But I wouldn't read this x1 is less than x2. I would read this as x1 is to the left of, because we know they're x values. Implies that f of x1 is less than f of x2. So we have 2 points on some open interval. This open interval could go all the way along here, and there's just 2 points that happen to be on it. And that could be any 2 points provided x1's less than x2. And then it says f of x1 is less than f of x2. Well, another horrible way to read this. We ought to read this as, of course, we know f of x is just a fancy name for y, but this is the height. It's a y value. It's the height at x1 is less than the height at x2, which means the height at x1 must be below the height at x2, and that's for any 2 points along this interval. It just says as we move from the left to the right, from x1 to x2, any one of the points along there, any 2 points we pick, provided we put the point to the left in this position and the point to the right in this position, the heights of this point is always less than the height of that point. Well, how simple is that? All this is really saying is that a function is increasing on an interval if it is always moving up as we go to the left. So this thing's just always moving up as we go to the left. That's all it's saying. So we learn to read this thing a little bit differently. It says if I have a point to the left of another point, and the height of the point on the left is bigger than the height of the point on the right, then the function's going down. Pretty simple, but that's why learning how to read math becomes pretty important. Um, Things can sound a lot more confusing than they are. A function f is constant on an interval if any 2 points on the interval, if any 2 x values on the interval. So let's say we've got an interval along here to here, and I just choose 2 points, here and here. If for any 2 we choose, the heights are the same. And that can be any 2 points along here we choose, the heights are the same. Well, of course that's constant. So just learning how to read and interpret that is something that I think is very, very important at the level you're at. Here's another definition of relative minimum, relative maximum. Let's use some of our new reading skills. This says a function value f of a, but this says the height of a function at a, at x equals a, is called a minimum of the function if there exists an interval x1 to x2 that contains a. So I've got some interval, let's say from x1 to x2 that contains a in it. Let's just say a happens to be here, that contains a, such that x1 is to the left of some point x is to the left of x2 implies that the height at a is lower than the height at any of those points x. Any point x along that interval, the height of A is lower than all the rest of the points. Something like that. That would say that on that interval, this is the minimum. Well, no kidding. If it's the lowest point on that interval, if it's lower than all other possible values of x that fit in there, it's a minimum. It's a relative minimum. Likewise, if the height at A is bigger than all the possible x's along an interval, it's the highest point. We may have some other points around it, but this would be point at A on an interval from x1 to x2. It's the tallest point, so it's a relative maximum. I always like to say this about relative maximums and minimums. They don't have to be the biggest point on the graph. They just have to be the biggest point in their or the biggest house on their neighborhood. Okay? So again, that's more about learning how to read math. I would use terms like the height of and to the right, to the left, than just f of x, f of a. Put some meaning to it, something you can visualize. This is a beauty. This is really, really simple to read, but the wrong way to read it is a function f is even if for each x in the domain of f, f of negative x equals f of x. If we were to consider x to be a positive number, which I know it can be a negative, what we ought to read this as is the height to the left is equal to the height to the right. So that would imply that if I have, say, this point on there, 2, 3, if the height to the left is the same as the height to the right, then this is called an even function. And we immediately see that that implies symmetry over the y-axis. And I'll often say this: you take yourself back to kindergarten, you finger paint on half a piece of construction paper, you fold that piece in half, you open it up, and you have a mutated butterfly. That's an even function. Mutated butterfly. Everything to the right looks the same as everything to the left. So how do we read this guy? A function is odd if the height to the left is the opposite of the height to the right, which would imply the height to the left is the opposite of the height to the right. So if I go to the left 3, my height should be the opposite of this, or down here, which implies either symmetry through the origin or 180-degree rotational symmetry about the origin. So really easy to understand, but when I think of even functions, I guarantee you I'm not thinking of this. I'm thinking of mutated butterfly. When I think about odd functions, I'm thinking about symmetry about the origin. One nice thing about even and odd functions is they both incorporate this idea of the height to the left, or the height in the opposite direction, if you like. Okay, here's some simple little functions. This is a piecewise function. Doesn't look totally simple, but in function speak or factory speak, I would think of this thing something along this line. We have 3 options of how we're going to handle numbers. So our Keebler's elves in here, our cookie factory elves, we would put one little elf right up here who is waiting for items to come in here. These, of course, are our domain items, or our x's, and we might just add 5 to those if x is less than or equal to -3, or we might just call them -2 if we're between -3 and 1 and 1, or we might call those 5x minus 4 if the value x is greater than or equal to 1. So I have a little distribution elf here who sends things to the appropriate place. But it's really, really simple. If we create a quick little t-chart on this, we could probably do this in our head, but if I pick a value less than -3, for instance, -5, I put -5, it goes to, we'll call this A. It goes to conveyor belt A, and we get -5 plus 5, 0. -4 goes there, -4 plus 5, 1. And negative 5, or excuse me, negative 3 would also go there, but just barely. It almost qualifies for B. It goes there and becomes negative 3 plus 5, 2. So I plot those, 1, 2, 3, 4, 5, negative 5, 0, negative 4, 1, negative 3, 2. I'm going to make that an extra big dot because that's kind of a stopping point where things may change. And then I look, it appears to be in a straight line. Well, of course it is. It's going to continue that in this direction. Then, second part of this, now I'm going between negative 3, let's do this in red, I'm going between negative 3 and negative 1. But because negative 3, I can put in negative 2.99999, I'm going to go ahead and just start here at negative 3. And if I was to mistakenly send, my elf was to mistakenly send negative 3 here, they would get out negative 2. So at negative 3, negative 2, I'm going to put a circle which just kind of builds a force field around that point. It says you can get really close to here, but you're not touching. And then if I send negative 2 there, I get a negative 2. And if I send negative 1 there, I get a negative 2, all the way until I send 1 there, and I get a negative 2. So I get negative 2s all the way across to right here. But 1 doesn't quite go in there, so we have that. Okay, and now let's go ahead and send numbers bigger than or equal to 1 there. When I send 1, my little sentry elf sends those guys down here, and I get 5 times 1 minus 4, 5 minus 4, 1. 1, 1, solid dot because we can be equal to 1 there. And then I send 2. And when I send 2 in there, I get 5 times 2 minus 4, 10 minus 4, 6. 1, 2, 1, 2, 3, 4, 5, 6. And then I'm going to make this a big dot. That's kind of a stopping point. And then on observation, I realize, hey, this is just a line with slope 5. So there is our piecewise function. Takes a little bit of time, but there's no one difficult thing about that. Okay, determine whether the function is even, odd, or neither. Well, remember what our definitions were? There were things like if the height to the left is equal to the height to the right, think about that. What does it look like? If the height to the left is equal to the height to the right, oh, that's our even function. Okay, so I'm going to just figure out what happens when I go to the left or put in negative x. I understand x can be a negative for those of you that want to be technical on it, but think of it as the height in the opposite direction then. So this would be negative x to the 6th minus 2 times negative x squared plus 3. But the 6 absorbs the negative in front of the x, so we end up with positive x to the 6th. The 2 absorbs the negative in front of the x, minus 2 times x squared, plus 3, and we quickly see that f of negative x is equal to f of x. Beautiful. So we know right now that this is an even function. We know that our height in one direction is equal to the height in the opposite direction. Even, odd, neither. Here's the beautiful thing about this. The test for even and odd is the same. I want to know what happens to the left. For instance, this is an odd function if the height to the left is the opposite of the height to the right. So my strategy is exactly the same. If my height to the left is the opposite of my height to the right. So the strategy is the same. I don't know if this is odd or not. Let's go ahead and try. I just want to figure out what f of negative x is. That would be negative x to the 3rd minus 5, or the negative does not get absorbed. 3 negatives times each other is negative x cubed minus 5. So is that, it certainly is not equal to f of x. It's not even. Is that the opposite of this? No, the opposite of this would be times negative 1 would be negative x cubed plus 5. So this is, so f of negative x is not equal to f of x. It's also not equal to negative f of x. This is neither even nor odd. Okay, so that's a great thing about even odd functions. The test is exactly the same. We just put negative x into the function, see what we get. Find the coordinates of a second point of the graph. Love this problem. Okay, and you may want to graph this, but let's think about this for a second. A function is even if the height to the left and the height to the right are the same. So in this case, I went to the left and went down 7. So now I'm going to go to the right and down 7. Now my height to the right is the same as my height to the left. For an odd function, my height to the left should be the opposite of my height to the right. So my height to the left we have, my height to the right would be 5/3. It should be the opposite of -7, +7. And don't try to memorize that's one of the worst things you can do in math is memorize. Okay, all I got to do is make this one be the opposite sign, keep this sign the same for even, change them both for odd, and try to remember that. That'll work, might work through the chapter test, but it's going to fail you down the road. Understand what even graphs are. Even graphs, for instance, this appears to maybe be even, symmetric across the axis. Odd graphs, maybe something like this, except I missed the origin. Symmetric about the origin, this symmetric across the y-axis. So, A, what do I know about even graphs? I know that the height in the opposite direction should be the same. What do I know about odd graphs? I know that the height in the opposite direction should be the opposite. Height in the opposite direction should be the opposite. What do I know about even graphs? The height in the opposite direction should be the same. The height in the opposite direction on even graphs should be the same. What do I know about odd graphs? The height in the opposite direction should be the opposite. So there's even and odd functions. I think it's really beneficial to think of the picture, not the written abstract rule. Okay, hope that was helpful for you. There'll be one more show that you may want, or one more presentation, one more video regarding 1.3. Thank you very much for your time, and look forward to seeing you soon.